be getting mock questions as well.
All right, sir. So, what is the agenda for today's meeting?
Today's agenda will be, I think, already week four sessions has been discussed. Sorry, week four concepts has been discussed, and I hope practice questions were also been discussed, I guess. If practice question has not been discussed, we will discuss the practice question. Else, we'll take this as an open session. If any
Oh,
doubts were there in activity question or any lecture slides or whatever, we'll take in this session.
okay, sir. I think we should start with practice questions of week four. The assignment, we have the grade assignment, and before grade assignment, there is a week four practice assignment.
Isn't it solved in last live session?
Sir, my PYQ question is related to V4. Is there any possibility we
Uh,
can discuss
okay,
that also? Only two
then
questions.
okay, then we can discuss at the end.
So at the end, oh, okay, sir.
So week four, practice assignment question discussed or not? Else we'll discuss practice assignment four questions. Can someone?
Sir, I don't know. Actually, I was not present in the last session.
Because what I got to know is it has been discussed. That's why I'm asking you if someone have any doubts there. Also, we can have a discussion. So no one attended the last live session, was it? Okay, fine. I think it has been discussed. You can watch it later. Practice assignment four questions. So and we'll take up activity questions then. If you guys don't have any doubts, I will go with activity questions. Is my screen visible? Hello.
Yes, sir, it is.
Okay. So it's almost straight away easy question. Let's discuss this quickly. The question says we can always find at least one pair of students with same date of birth in a single iteration. Is it possible to find a pair of student in a single iteration?
No, sir.
No, right? So minimum you need two iteration. So this is false. And the second question says two nested iterations are sufficient to find pairs of students with same date of birth. Is it true? This is true, right? You need two iterations to find a pair of students who has same date of. Like any doubts here? Like if you guys have any doubts, please stop me and you can ask a question. Okay. So the last question in this activity question is they have given three statements. Student X is compared with another student Y from pile 1 and repeat statement until pile 1 is empty and the date of birth of student X does not match with any other student in pile 1. So using these three statements, what we can say from the below options? So the correct answer is we can discard X and keep Y for further iteration. Because the Y will be the first iteration, right? It will be like this while pile 1 is not empty. Not empty, you will be reading the card, right? Read card from pile 1. See here the student Y is from pile 1. So what we will do, you will keep this for further iteration and again there will be another while pile 2 is not empty, you will read the card and you will compare, right? The card X and equal to Y or not. So this will be your X and this will be your Y. Once you read, compare all this, you will be discarding and you will keep Y for another iteration. So any doubts here? Okay, let's move to next activity question. Oh, here it's about the binning strategies, right? What are the possible binning strategies to find a pair of students with the same date of birth? So we can bin by month of the birth or we can bin by day of the birth, right? We cannot bin by city or range of marks to find a pair of students with the same date of. Okay. And if the bin has at most one card, there's no need to iterate that bin. Is it true or false? True. This is true, right? If the bin has a zero or one card, this is what it says, at most one card. So there is no need to iterate that bin. You can easily say you don't need to iterate it because it has all equivalent to one card. And next question. One iteration is sufficient to bin the cards. Is it true or false? True, right? Using one iteration, you can check for a condition and you can bin it, right? Suppose if you take a marks from 0 to 100 and suppose you bin it with file like this 20 to 40, 40 to 60, 60 to 80, and 80 to 100. So I'm roughly writing it, okay? So if you take a bin like this, you can, within a single iteration, you can increase the number of cards, and you can check this condition and can put it. So within one iteration, you can able to bin all those cards. And the next question is, we can solve this birthday paradox problem after binning in one iteration. Is it true? No, right? Sorry, this is false, right? Still, you need two iteration to solve this. And the advantage of bin in this, it reduces the number of comparisons, right?
Yes.
Then we'll move to next one. So I hope this is the straight away formula from the lectures, I guess. So we have n cards in a pile. We have to compare each card with every card pile exactly once. So the total number of comparison will be n into n minus 1. This is, you might have seen in stats 2 as well. This will be nothing but it will be equal to nc2. And you can represent this into n minus 1 by 2. Okay. So remember this formula. We'll be using this for next some of the questions. So here, so what they were asking is, if we connect each element with every other element by lines, what will be the total number of lines that we have to draw? So see, we have to take a condition, like we have to draw a line like this. So we have to connect every other nodes. Generally, we used to say nodes, and here we represent it. So this one and this one. So the total number of lines you connect with other six elements is six here. 1, 2, 3, 4, 5, 6. If you take B, you have already connected to A, and you don't need to connect to A. Now the total number of lines to connect other elements will be 5, right? And if you take C, you don't need to connect with B and A, because since it's already connected. So every time one line will be reduced for connecting to other elements. So this will be nothing but it will be equivalent to n into n minus 1 by 2 formula. And total you have 7, right? So 7 into 7 minus 1 by 2, which is nothing but 7 into 6 by 2. If I cancel it out, it will be 21. So the answer will be 21 here. And the next question, as mentioned in the lecture, they have given the, right? A computer can do 10 to the power 8 comparison in a second. And how many seconds will it take for a computer to do pairwise comparison of 1 million elements? So this 1 million element, I can refer as 10 to the power 6, right?
Yes, sir.
So the total number of comparison that we have to do will be 10 to the power 6 into 10 to the power 6 minus 1 by 2. This is the total number of comparison that you will be doing, right? And there will be some answer, you will be getting it. the answer you will be getting it, if you divide by 10 to the power 8, this will be roughly equal to 5000 seconds. Not exactly, roughly, it will be equal to 5000.
But sir, I am not able to visualize this question, that how do you came to this conclusion that we will use here the same formula for.
Okay. Here, what they were asking is to do a pairwise comparison of 1 million elements. If you want to do pairwise comparison of 10 elements like this, what you will do, 10 into 10 minus 1 by 2. This will be your number of pairwise comparisons, right?
Right, sir.
So similarly, we are using the same one, 10 to the power 6 into 10 to the power 6 minus 1 by 2. So this answer is nothing but the number of comparison that the computer will take. Okay. And the question itself, they have mentioned 10 to the 8 comparison per second. If you divide by 10 to the power 8, you will get the number of seconds it will take to compare uh, to this 1 million elements.
Sir, why do we divide with 10 to the power 8?
Why do we divide?
To get the number of seconds, because in 1 second it does 10 to the power 8 comparisons.
So then we should multiply.
If you are multiplying, I don't know how it makes. You should divide, right?
Because it's pairwise. I think we should multiply then, because we want pairwise.
No, no. This is number of comparison that it will take. It's the answer you are getting after this. It is number of comparisons only. The question says 10 to the power 8 comparisons, and you should divide to get the number of seconds to do this much of comparison. Whatever the answers you got.
All right, sir.
Okay, then we will move to next activity question then. Um, active ones. Okay. So all this is based on the same formula and the number of comparisons. We'll use this same formula n into n minus 1 by 2. So assume that we have 20 objects that needs to be compared. How many pairwise comparison do we need to make if each object is compared with every other object exactly once? So simply they were asking the number of pairwise comparison, right? So can simply substitute it into 20 into 19 and just using this formula. So this will be 190. And next one, the question is, assume that we can distribute 20 objects into bins of equal sizes. So that means there will be 4 bins, right? Into bins of equal sizes means, so it will be nothing but 0 to 4, 5 to 9, 10 to 14, 15 to 20. Sorry, 0 to 5, I guess, considering it starts from 1. So 15, 16 to 20. So there will be 4 bins. And the question itself, they mentioned if we go with 4 bins, how many comparison would we need to make overall? Right? So what will be the answer here? First, you need to check
Four
how
bins?
many.
10.
40 it will be, right? 4
10
into
per
3
bin
first.
into 4.
Hmm.
40.
Hmm. It will be 40. So if you multiply 4 into 3 by 2, this will be 6. And so I'm missing something here.
5 will be there in each bin. So 5 into 4 by 2.
Yes, right. 5 into 4 into 2. So there will be 10 comparisons. And again, for 4 bins, there will be for any doubts here?
Sir, if there are 4 bins, why doesn't the comparison was like 4 into 3 by 2? Why 5 into 4 by 2?
So each bin will have 5 objects, right? Total 20 objects. If we divide into 4 bins as they have mentioned in the question, 5 objects will be there in each bin. So this is the number of comparison for each bin, then we just multiply into number of bins.
Okay, sir.
So the next question is, we distribute the 20 objects into bins of equal sizes. Here they haven't said how many bins, uh, that's not given here. They, instead of giving, they were asking to us how many bins should we choose to make the least number of comparison overall. So how can we solve this?
Sir, higher the number of bins, lower the number of comparisons, right? Or is it inverse of it?
Uh, you have to check with the formula. I'll just give you a hint. Okay. So if you wanted to choose the number of bins, you can say 20 to the power k. This is nothing but 20 c to the k, right? So
Can we make 2 bins of 10 objects each?
yeah, that is the answer, but how can you solve this?
Because it is given in the question, so it is our choice that how many bins should we choose to make the least number of comparisons overall.
Hmm.
So if I, 10 is for to be 2 bins, I think 10 is the only number which because 10 into 2 is 20. So I think
Uh,
that is the
okay.
reason according to me.
If it is 10 into 9 by 2, then it will be 45. Into 2 bins, it will be 90, right?
Right, sir.
This is for n equal to 2. Sorry. This is for 2 bins. I'm multiplying with 2 bins. This one, it will be the answer. So what if it is 10 bins? If it is distributed into 10 bins, so for each bin there will be only 2 objects. So if you take 2 into 1 by 2, this is nothing but equal to 1, and 1 into 10, it will be only 10 comparison. This will be the least. So the answer will be 10. If you wanted to solve mathematically, we can use this 20 into n. This why we are dividing by n is because we don't know what is the number of bins that we have to choose, right? So we can just multiply into n minus 1 and divided by 2. If you
Sir,
solve this,
yes.
yeah.
Sir, what if we take only one bin?
What if you take only one bin?
Yeah.
Then 1 by 2 into 20, again 10. But how can you take 1 by 2 objects?
Uh-huh. Right.
Okay. The next question is based on question 1 and 3. What factor does binning reduce number of comparison? Can anyone? Can anyone explain this? It's very simple, right? First question we saw the 190 as an answer. Here we saw 10. So what they were asking is by what factor does binning reduce the number of comparison? So this is nothing but without binning, right? And this is the binning. I can say this is optimal binning. So if you just divide it, 190 by 10, you'll get 19 as the answer. That is your factor binning reduces number of comparison. Any doubts here?
It wasn't mentioned like it should be a common factor or anything like that.
No. They explicitly mentioned, right? Based on question 1 and 3, by what factor the binning reduces the number of comparison.
Okay, sir, understood.
So next question, what they were asking is, you want to find the number of pairs of students who satisfy both the conditions given below. Both students in the pair have the same total mark, and both students do not belong to same gender. So we now divide the students into 2 bins, one which contains boys, one which contains the girls, and perform pairwise comparison with the bins. Will this approach give us the correct answer to the number of pairs? Anyone? It's too straightforward, right? By looking at the question.
I think yes.
No, right? See, the question has two conditions. Both student should have a same total mark. One is same total mark, and another one is not same gender. Here they binned it, one bin with only boys and another bin with only girls.
But can't we do comparison between those two bins?
No, right? How will you do?
If we find the answer, we can separate the students into bins by their total marks.
Yeah, that is the correct answer. If you bin the total marks, you will be able to get into and check with same gender. So the answer to this is no. And for the next one here, it's too easy. We have about birth dates, year, month, date of 100 people in a room. We wish to find the number of people who born in the same year. So which of the following would be an ideal binning strategy? Using a year will be ideal binning strategy, right? Because they wanted to find based on year only, you born in same year. So we can use 12 bins, one for each decade and starting from the year 900, 1900. So if you are using two bins only for the year, it will increase the number of comparison as we have seen in the previous question, right?
Yes, sir.
There is use more bins for this more than 12.
Okay. Let's then move to next one, 4.5. Now this, yeah. So the question is too simple, I guess. We have two students X and Y who satisfy the following condition: X plus max, X plus physics equal to Y dot max, Y dot physics. So in order to be true for this condition, it could be either like this, where X max and Y max are equal, and the same time Y X physics dot Y physics are also equal. So this is very clear, I guess. And another condition would be if X dot max is greater than Y dot max, so X dot physics should be less than Y dot physics, right? So can for this one you could take some of the numbers and you can experiment with yourself. For this one also same. If X dot max is lesser, X dot physics should be good. So these three options will be true.
That is third and the fourth option. Sometimes it is not possible.
Sometimes it's not possible. Mm, but it could be, right? This two cases. But in this case, definitely it's not possible. They were asking only possible scenarios, not exactly true. Any doubts here?
No, sir.
Okay. Okay. The next question is count the number of students in the bin 201 to 225 and the endpoints included. That means we need to consider 201 and 225 as well, and store the result in a variable. And assume that a variable has been already initialized to 0. So here what they were doing is here they are reassigning it. They are not incrementing, right? So this is wrong. And here this one is true because I can say it satisfies the condition 201 less than or equal to, and sorry, less than or equal to x total, again less than or equal to 225. So this is true and they are incremental. And this condition also satisfies, right? Because it's not it is strictly greater than this 200.
Sir,
So
in
this
this
is also
question, I have in this option only, I have one doubt.
hmm.
It should also there's a possibility that it shouldn't be correct because it is possible that the number could be in decimal also. Like this only less than and greater than excluding equal to includes the possibility that number could be in decimal form also. Like 225.5.
225.
0.5.
Okay, for this one, right?
Yes.
Okay, in that case, that's not, but you are assuming this as an integer only, right? Because we used to count the number of students in the bin 201 to 225.
The data
So
is discrete, so it cannot
assuming
have
that it
decimal.
is assuming that is a discrete and they are considering as marks, so this is also correct. If it is decimal, as you said, so then it's not correct. Okay, then this is also true because basically you are incrementing if both these conditions satisfies. It satisfies again, it's equivalent to this only. If x is greater than 201 and if x total is 225, then only you are incrementing. So it if it passes two conditions, then you are incrementing. So this is also true. Any doubts here?
No, sir.
Okay. Yeah. So okay. Now consider this pseudocode is left heavy m n is nothing but total marks. Let's say assume this has total marks of two students. If m dot total minus n dot total greater than 0, returns true. It's nothing but if m is greater than n, you return true. If this is else, you return false. Right? I can simplify this into like this. I can say like this, right? Based on this.
Sir, first and third option is correct. They will return the value false.
Okay. So if is left heavy returns the value equal to false, so that means your second value is greater. So if it is, it will be negative value. So this return false. And even if it is same mark, it will be equal to 0 and again it will return false. Because it's not saying greater than or m greater than or equal to n. Right? Okay, the next question is the return value of is left v x y is always opposite to return value of is left v y comma x. Is it true or false?
False.
Why is it false?
X is greater than Y.
Let's say this x is 85 and y is 58. So if you are taking this, it will be true, right? Is in opposite manner if you reverse it, and it will give you true and false, right? Because if you pass this is left AV or not, so this will return true. If you just reverse it, 58, 85, this will return false. So they were saying it's always opposite to the return value. But there is a case if you pass equal marks like 85, 85, 85, 85 to both after the interchanging also, it will always return false. This will also return false. This will also return false, as we have seen here. If it has
This
total.
question I didn't understand. Can you repeat this one?
Okay. Just so this question is clear, right? Third one.
Yes, sir.
Okay. So what is mean by left AV here? If the mark you are passing here in x, if you are passing greater value like this, something like this will return true, right? Because the
Yes, yes.
this, let's consider this as x and this as y. If the x is greater than whatever, if you take x or y, whatever the value you are passing in the first argument, this first argument, if it is greater than second one, it will return true. And if you reverse it, will it return true or false?
False.
False, right? So let's see what the question is asking. The question says the return value of is left v is always opposite of the return value of left v of y of x. This is what we have done. This is just opposite of this, right? Is the return value is also opposite? Here it's returning true, here it is returning false, right?
Right. Yes, sir. Got it.
So here it's satisfies this condition. If you pass a equal value, something like 85 and 85, and like is left v, this will return false. Again, if you reverse it, it's nothing but again 85, 85 only. Again, this will be also be false. So in this case, this statement is not true, right?
Oh,
Whatever the statement they have given.
yeah.
Okay, that's why it is false. Have we got this question?
Yes, sir.
Okay, let's go to next one. So here they have given a question using a pseudocode. The function called mystery passes m and n, and we are asserting this m and n as argument here. If left AV mn equal to false, is left AV in a reverse order, they just passes reverse, right? nm is also equal to false, then they are returning true. And else false, or else false again. So using this, what you can say?
Same total marks.
Third
Same
option.
total. Third option, same total marks, right?
Sir, what happens when we change this mn to nm? Is it something like ordered pair or not?
Yeah, they're not checking for any ordered pair, right? They're just passing the argument in a reverse order, like 98, 89. And here they pass as 89, 98. If both were false, they were returning true.
All right, sir.
So
Understood.
this 2 will become false only if it has equal marks, something like 85, 85, then only it will become true. Otherwise, it will execute this and this.
And why it is two else is there with return false? Why not only one?
Why not?
Why not only one else return false? Why it is
Okay. If you, let's say this condition itself not satisfies. If I pass a value, let's take 3 scenarios, okay? 69, 78. As I said, one is 98, 89. And third scenario is where both of the marks were equal, 75, 75. In first case, it is 69, 78. Is it equal to false? The first condition matches, right?
all right?
False, right? So
Yes, sir.
if this is false, you take this if condition as true, then it will go and check this if condition. In this if condition, it just reverses and unchecks 78, 69. Is
Okay,
this
sir.
if condition returns true? No, right? So in this case, this code of block will be executed, right? As this one.
Yes, sir.
So, but if you take the second one, 98, 89, here itself it returns false. I mean, the if condition will be false for you because this is left heavy and it will return true. So it will be true equal to false. So this will be false. So directly it goes to this and it will execute this.
Okay, sir.
So if it is both having same marks, it will come here and it will execute this.
Understood.
And if we take only one else, then also this pseudocode will be correct, right?
Sorry, I'm not able to hear you properly.
I'm saying if we take only one else return false, then also the pseudocode will be correct, isn't it?
No, right? If this is not there, what is this pseudocode correct or not? That's what you were asking, right?
Yeah.
It won't be correct because it won't return you anything. If this condition falls after this, see, if you wanted to write it, it will return. So in this case, it will return some value called null, right? Because it won't return true or false because this condition doesn't match. It comes out of this if loop and it checks. It couldn't execute any code and it will return null only because there is no return statement after that.
It checks the second else, not the first one.
Like, have you got this?
I'm asking why the written value, I mean, if left heavy m comma n is equals to false and it returns to else return false, the second one. So why it is
Hmm.
going to the second one, not the first one?
I'm not getting why it is going here or here. This is what you're asking.
I'm saying if the first condition is not met, then it can go to the first else return false now. Why it is going to the second one?
I'm not getting what exactly you were trying to say. So if this is false, this if condition is false, it will go to this else only, right?
I'm
Because
asking
this
why this is going to the second
because
else.
this if is belongs to this else. If you one read the syntax, uh, and this if is belongs to this else, not this one. So this is the way of writing the code. So this if and else will be in straight line. So you can say this if goes to this else, and this if is go to this else. You need to carefully check this curly parenthesis also. So where this if condition ends is here. If condition starts here, this if one, first if, and it ends here only, not here or here. This is for the second if. So this if starts here, this if ends here, then it will go to this else only, not this one. If you go and take and look at this if which is inside it, and it starts here and this ends here itself. This is called as in if within if, you can say. If it ends here, it will execute this. After this, yes, this will be there.
Got it.
Okay. So let's have a look at this code block. Here, this is the code block one. The question says if both data of birth are equal, return true, else return false. And the second code block says if both date of birth are not equal, return false, else return true. So this both will it's saying the same thing, right? It just written in an opposite manner. It's correct, right? It is, yes. Both code blocks are equal. This return will of course return if x dob equal to y dob. If it is not equal, then it should be equal, then only it will return true. And this will be nothing but x dob not equal to y dob. Because if here it is equal, so this should be definitely not equal. So both statements, sorry, both code blocks implying the same thing. It's code block. This one. second and third question, this is the pseudocode that we'll be using. Here, the statement 1, we have to fill it up, and statement 2 also we have to fill it. So what they were asking is, we wish to use this code to find a pair of students in the data set with the same birthday. So we need to find a pair of students who has the same birthday. So in this case, what should be my initialization value? So for statement 1, it will be false, right? Initially, you take variable as false, then only you go and look for the pair of statement. Otherwise, you don't even need to look inside the statement because the condition here itself false. If you initialize with true, this code even won't be executed and you won't be able to find the pair of student who's having same birthday. And next, if it is going and iterating here, and you are picking a card from pile 1 and moving it and checking with it, and if it has same birthday, assuming that this function returns, if it has same birthday, it will return true. Otherwise, it will return false. So assuming it returns true if it has same birthday, so the statement 2 will be found equal to true. Once this becomes true, this loop will terminate because it is an AND condition. The found will become true. So this loop will terminate, right? So the answer for this is found initially for statement 1, it is false. And for statement 2, it is. Any doubts here?
No, sir.
No, sir.
Then this is leave for you to solve because you guys need to check dataset, nothing difficult. So does the paragraph word dataset provide the information about personal nouns pronouns to resolve pronoun with its equal matching noun? It is no. So you can, if you check the dataset, it will be clear. Okay. Any other doubts apart from this? Otherwise, it's already 7:15. I hope you guys will be enjoying the Diwali and you came to the session in between. Hello.
Yes, sir.
So, do you guys have any doubts in week 4 session on this?
No, sir.
Okay. Yeah, Vibhu.
Sir, I
The
have
week
a
4 session.
sir, I have a doubt in activity 4.3, question number 3, sir. I'm joining late, sir.
Just sure, okay. Could you please rewatch the session?
What, sir?
You can watch later on YouTube, right?
Yes, sir.
The link of this recorded session will be provided today.
Right, it is in the YouTube.
Oh, Okay.
Oh, okay. Then I think we can wind up the session, right? Or if you guys don't have anything.
Thank you so much, sir.
Thank you, sir.
Thank you. Okay, thank you everyone for joining, and wish you the happy Diwali.
Thank you, sir. You too, sir.
Same to you, sir.
Okay, bye bye.
Take care.
Sir, is this class over or not?